Good morning, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe here at Hanover Fairground 2023. Hello also to all our online guests. I welcome you to come and have a seat and enjoy all our lovely presentations. We are here at the technical forum. That means we get technical. My name is Mona. I will be your moderator for the whole day. Our upcoming talk will be discussing the standardization of hydrogen refueling stations. We'll talk about HRS 2.0. If you want to know more about that, stay tuned and welcome with me on stage the sales engineer of Maximator Hydrogen, Mr. Christian Bomm. Welcome.
Yeah, thank you, Mona. And welcome to our presentation HRS 2.0, the standardization of hydrogen refueling stations. Last year we released here our new compressor Max Compression 2.0 exactly here on this stage. This year I'm extremely proud to introduce you to our HRS 2.0 concept. So I think it's well known that a single compressor is far away from being an H2 filling station. An entire harmonized concept is needed for this. And this is exactly what we are good at in a serial production since 2019 in Nordhausen, made in Germany. So the first is that or the issues that we are facing today is first that we have interfaces on the filling side, for example, to some forklifts, to some heavy-duty vehicles on 350 bars, or to some heavy-duty vehicles on 700 bars. Second, we have a high variation on the station design, for example, in the number of storages that we are implementing, or in the number of banks that we are connecting to them. And last, the interfaces between the H2 source, like the electrolyzers or pipelines on different pressure levels, like drop and swap containers or trailers, for example. And for sure, in general, we are very pleased to recommend proven systems, but all interfaces are neither harmonized on internationally or national platform. So to illustrate the interfaces, I would like to show you the trailer connection, which is called Max Supply Panel. Here we have to clarify, for example, the length of the hose, the definition of the screw connection, which depends on the supplier of the hydrogen, and for sure the pressure level. Is there some pressured air needed? Is there electrical connection needed? Is there communication needed between the source and the refilling stations? Do we need some groundings, for example, from the trailer or to the trailer? Or do we have a number of banks on the trailer, like you can see here on the right side? So this is a trailer. So this is separated into 6 banks, pneumatic controlled. The standard, for example, in Switzerland is a 300 bar container with 3 banks. And on the market available are trailers up to 500 bars and separated in up to 9 different banks. So what is the status quo today? We have a high technical load on projects, which means that here is no fuel cell production on the overall process. So first we start with the concept, which is, by the way, the hardest job for the customer, because he has to know what he wants and what he needs for the refilling station. For example, what has to be refilled, light-duty vehicles or heavy-duty vehicles? Where have to be refilled? For example, there's a very big major difference from the United States or from the European Union, or a station that you want to implement in Switzerland, for example. How often do we have to refill the vehicles, and in which time frame do we want to refill this vehicle? So all this question has to be clarified before we can enter the engineering, where we have to decide what kind of models do we use. Do we have standards models for this case, or do we have to develop some new models? Afterwards, we go through the hazard with the interplay of all circumstances. So we have to check it locally and individually for every single refueling stations. And finally, the permitting. So maybe we have some requirements by the authorities, and that has to be checked before we can enter the real serial production at our plant in Nordhausen and for the civil works at customer site. And for sure, I don't even talk about some possible requests for change of our scope. This is my daily business. So we have always a good chance to get back to stage number 1 at the beginning. So what does it mean to the customer? Today we have models that we put together individually and adapt them locally. And after installation, we create a CE marking on the fully bit HRS overall. That means that it's more difficult in planning and permitting, and it's more difficult on the modification and upgrade later on. The good news is that this will be a story for the History Channel, because we will fix that. We will use the modular architecture based on an archetype. So that is a standardized model with predefined variation packages, which allows us a certain degree of variability. So this is more or less like putting Lego bricks together. That's the idea behind. So which kind of model do we need? Is it a recap just to refill drop and swap containers or trailers? Or can we use a normal dispenser? But what kind of dispenser do we need? Is it a dual dispenser with 350 bars and 700 bars? Or is a single dispenser maybe enough with 700 bars heavy-duty vehicles? What number of modules do we need? So is one enough, or do we need more of them? And for sure, what software or what kind of software can we need? So today, we are developing a new software for every single station. In the future, we would like to implement just some parameters on the standard software. So that would be a very big change. And for sure, the design pressure. So all our compressors are made for 1,000 bars. And the next step, the whole HRS has to be suitable for 1,000 bar systems in general. How do we get there? So the independence of each model makes it easy to combine the systems and exchange or expand it on the long term, which is a very important point. So this will allow us to react extremely flexible and changing requirements. So we don't look on the entire system. We can look just on the model that we want to change. For example, on the filling side, there's a dispenser. And if we talk about dispensers today on 700 bars, we are speaking about 60 grams per second on a very small chiller system on the T40 level and with the infrared communication. But that is not the situation from tomorrow. Tomorrow we are speaking about much, much higher mass flows, like, for example, 120 grams, 180 grams per second, or much more. And we will speak about other chiller systems like T10 or T20 level. And we will speak about the near-field communication. So this is the reason for the new dispenser design that we developed and that you can see on our platform. But this strategy involves all other areas of the HRS, also like the compression, the flow tags, the storage, and also for sure the interfaces to the source. And to develop this approach, we have predefined some plant types to increase the speed and come much, much closer to the goal of a real serial production. So the types includes also the well-known sizes from Switzerland, up to some major heavy refilling stations that you can supply the entire bus depots, for example, or logistic hubs. So here, for example, you can see the HRS in the form large, where we can implement up to 4 supply panels, we can implement up to 4 max compression systems, 6 banks of maybe 500 bar storages, or 6 banks up to 1,000 bar storages, and up to 6 dispensers for refilling vehicles, or maybe also to refilling some trailer and wrap and swap containers. But keep in mind, this is only the final stage of expansion. You can start for sure with smaller systems. So in a nutshell, we will simplify the warehousing because we are using just identical systems and components all over the world. We have shorter project times because short lead times and easy permitting. We have cost improvements because the serial production and time is money in general, for sure. And we have an easy repeatability. So that means that you have a station setup that works for Norway and Germany, that would also work for Oslo in Norway or for Switzerland or all over the world. And that's a very big advantage. And for sure, it is easy to upgrade and expand the systems because you can put it together like Lego bricks. Yeah? That's the idea behind. Thanks for your attention. Danke für eure Aufmerksamkeit.